K2-18b. No, it's not a character from Star Wars. It's a planet 2.5 times the size of Earth and 700 trillion miles away, and it could be home to living organisms.
Here's what we know right now, Pamela. The James Webb Space Telescope is so powerful that it actually can analyze the chemical composition of atmospheres from far, far away. And the atmosphere analyzed from K2-18b shows molecules that can only be produced by living organisms. In other words, it's a step potentially closer to directing life on another planet. For more, we're joined now by astrophysicist and NASA advisor Paul Sutter. Paul, this is potentially an extremely exciting finding. How compelling is the evidence of life on another planet?
Oh, this is definitely very exciting and very interesting. But I have a personal mantra when I encounter results like this, which is if it's interesting, it's probably wrong. And that helps me temper my enthusiasm and my geekiness, excitedness with a healthy dose of scientific skepticism, which we need to approach these kinds of results. Now, the evidence here is certainly the strongest evidence we've ever had for life on another planet. But in an absolute sense, the evidence isn't all that strong. It's a very weak signal here of these elements. And even if these elements are on the planet, it's not necessarily generated by life. We are at the very, very edge of what we can discover and detect with the James Webb. And it will take a lot more analysis, a lot more study, a lot more investigation to rule this in or rule this out, which is how science progresses.
We were looking for you to say, hey, this is proof that aliens exist, but clearly you're not going there.
I was going to ask you if we could actually call and speak to somebody a few hundred trillion miles away.
We can definitely make the call, but you're going to have to wait for that response.
All right.
So what does it mean? You know, we talk about life on another planet. I mean, this could be a wide range. Right? Array, I should say, of the type of life that could be there, correct?
Absolutely. Like, we're the only known living creatures in the universe. We don't know the true variety of life out there in the cosmos. We are hunting for life like our own because we know what it looks like. We know what it does to planets. We know how it alters the chemistry of an atmosphere. And so this planet, K2-18b, it has water vapor. It has methane. And in the latest discovery, it has dimethyl sulfide, which is made by algae on the Earth. Is there some sort of alien life here? We don't know. But it's very intriguing. In this world, I should say this world is completely unlike the Earth. It's twice as wide. It's 8 times as massive. It orbits a small red star. It has a year that only lasts 33 days. If there is life here, it is truly alien in a very real sense.
Walk us through the science a bit. How does this telescope actually work? Because this planet is, what, trillions of miles away?
This is fascinating. This is exactly what the James Webb was built to do. This is what we waited so long to be able to accomplish. We're not taking pictures of this planet. This thing is way too tiny for that. All we get is the light from its parent star, which appears as nothing more than a dot of light, even with our most advanced instruments. But what happens is that this planet in its orbit crosses in front of the face of that star. And so the light from the star filters through the planet's atmosphere on its way to us. And then any chemicals, any molecules in the atmosphere change the light from that star, and we can pick up that change and figure out what's in the atmosphere. The fact that we can even do this, that we can say, oh yeah, there are these elements on this planet 700 trillion miles away, is a testament to just how powerful James Webb is and the creativity and ingenuity of my fellow astronomers.
Yeah, I mean, really remarkable, right?
Amazing.
The people who built that and all that goes into it. Are you concerned about NASA's science budget and how that could impact further discoveries like this?
Yeah, I'm scared, and when I'm not scared, I'm exhausted, and when I'm not exhausted, I'm scared of what's happening to science in our country and the future of science. And I empathize with people. I really do. I understand that if budgets are tight, if times are uncertain, uh, things like the James Webb, things like looking for life outside the solar system, things like astronomy, seem like unnecessary expenses. And yeah, this is extra stuff.
Mm.
Also, if we were to eliminate all of NASA's budget, nobody's life in the United States would change. I mean, it's not going to affect our bottom line. We take the tiniest fraction out of the federal budget to make this kind of stuff happen, to make our science advance. And what we do is make the world a more beautiful, more wondrous place. What we do is create exciting news for us to talk about and think about.
Let's bring in Professor of Astrophysics and Exoplanetary Science at the University of Cambridge, Niku Madhusudan. Not only is he part of Cambridge's Institute of Astronomy, he's also the lead researcher of the evidence of life beyond Earth. Professor, we've been so looking forward to this conversation with you. This is rather exciting, and you call this a revolutionary moment, as it is the first time humanity has seen potential biosignatures on a habitable planet. And it all comes in the form of a molecule, as Zane had described, which is exactly a similar molecule that we have here on Earth. What is the significance of this molecule?
Yeah, hi, glad to be on here. The molecule DMS and potentially one other molecule, dimethyl disulfide, we are seeing hints of at least one of the two molecules, maybe even both. And both of these molecules are known to be uniquely produced by life here on Earth, mostly by microorganisms and organic matter in general. And the amounts that we are seeing on this planet, it is currently, we don't know of an abiotic process, non-biological process that can cause these molecules in the atmosphere at the levels we are seeing. So that is sort of the hints for biological activity that we may be seeing. But we also want to be extremely careful at this stage. This is very early stage, and we don't want to rule out non-biological processes, but I want to take a step back, and for us as a species to appreciate how far we have come. Even the act of being able to detect these molecules in a habitable zone planet 120 light years away is a huge technological achievement. And that, in my mind, is the real breakthrough for us as a species, how far we have come as an advanced civilization.
When you put it like that, I mean, it's incredibly humbling. Not just the fact that we're seeing signs of potential life on another planet, but just, you're right, how far we've come just in terms of the science and the technology to even be able to detect the compound known as dimethyl sulfide, as you were just mentioning. So how do we know for sure, or when will we know for sure, probably is a better question, if this planet is actually habitable?
Yeah, so we don't have a definite timeline. Obviously, this is a major area of study, and we don't want to quickly go to conclusions whether we have detected life. We want to take our time, and we have done that for this observation as well. We have taken our time, did very robust studies, but we want to do more observations to confirm if the signal that we are seeing is real, and we want it to be confirmed robustly at a confidence such that there is less than 1 part in a million chance of it being a complete fluke. That is the level of robustness we are aiming for here. We are not there yet. We are a few parts in 1,000 chance of a fluke, but we want to go much farther. And we also want to do theoretical studies and experimental studies to make sure that there is like no other abiotic process that we have missed as a field that could explain these abundances. But so far, based on the knowledge that we have currently, the only way we can interpret it is a biological process causing significant amount of these fluxes on this planet. But we want to remain open, obviously.
You talk about taking a minute to note the inroads and advances in technology and science that got us, and you specifically, we had nothing to do with it, it was you and your brilliant colleagues, to this moment. Can you speak to the impact of something as powerful as the James Webb Telescope and the role that it has played here in helping you as a tool relative to its predecessor, the Hubble?
Yeah, I mean, it's kind of you to attribute the success to me and my team, but actually, I think you are also involved in an indirect way. And the marvel that JWST is, it comes from remarkable efforts from thousands of people over decades, both NASA, ESA, the Canadian Space Agency, all of us as a society, as a civilization, are responsible for the technological marvel that is. And we have put that icing on the cake with our science, but fundamentally, that's how I view it, is that it's our contribution as a society where we are, that we're able to do this science, and it would not have possible without what these agencies have done for us, right? So it's all our result in that sense. And more specifically for this science, yes, we have detected these molecules at the level we are talking about here, and we want to remain open. And we'll see if this is confirmed. This is going to be a major transformational moment in the history of science. If this is confirmed, like maybe in a couple of decades, we might look back at science and think that that's when that breakthrough happened and that was its turning point. It is also possible that in a few years, we'll realize that actually there is another chemical process that could explain this, and that would be a discovery of new chemical process. So however you cut it, I think this is a win for science.